All set? All right. All right, welcome everyone to the Sunday morning talks. I'm sure you're all alert and awake. Lots of coffee, that's good. So this talk is called Beyond OWASP Top 10. Before I discuss what it's about, I'll get into who I am. So this is me. My name's Hnatiw. You can reach out to me on Twitter. It's @inspector with a 3 and an RE. Previously, right now I am a senior security researcher at Security Compass. Before that, I've been in a number of roles across security and IT. I am a software developer now. I do a lot of open source security reviews as well, write some security tools. I was a security consultant, system administrator, network engineer, developer, college professor. The professor part kind of comes into play here because I'm used to putting together classes for 3 hours, and trying to condense that down to 50 minutes is kind of difficult. So if I go quickly, I apologize in advance, but we're recording it, so if you need to go out later, that's fine. And after the talk, if you want the slides, if you want some more detailed information, please come up to me. You can always reach out to me on Twitter. If you come up to me after the talk, I'll give you my contact info too, so you can review it a little bit more after. So let's start. What is this talk actually about? This talk is about OWASP, and more specifically, OWASP's Top 10. For those of you that aren't familiar with it, the Top 10 is kind of the de facto reference that we give to developers usually, or we use ourselves when we're discussing web application vulnerabilities. Typically, what it is basically the top 10 most common web security vulnerabilities, or security vulnerabilities in web applications. It was the last full release was in 2013. There's a release candidate that's come out this year, but I'll get more into that later. So I'll go over the top 10, but you'll see it's used as basically categories of web vulnerabilities. And typically what happens is not only is it a reference for developers, but it's a reference for us, for pen testers, and when we're trying to help developers, is we categorize a lot of vulnerabilities through these things. And what this talk kind of goes over is 3 different vulnerabilities that don't fit within those categories. So it's to show that there's more than just the top 10. So I'm going to go over first the top 10 briefly, for those of you that have not seen it before. First one's injection. So think like SQL injection, where you can inject code and it gets executed really behind the scenes. Broken authentication and session management. If you can take over a session and authentication doesn't work, it falls under this category. Third one is cross-site scripting. It's pretty familiar to most of you, I'm sure, but it's basically allowing you to, if an attacker can execute malicious script, JavaScript usually in a client, in a user's browser. 4, insecure direct object reference. This basically means if you can reference an object that you're not supposed to access just by its identifier without any kind of other access controls to it, that's known as an IDOR. And then the security misconfigurations, number 5. This is a pretty broad catch-all. Just means you're not using whatever system's in place properly. So an example of that is like MongoDB. By default, there is no password on MongoDB, so if you open it up to the web, then your MongoDB your database is going to get owned. The last 5, sensitive data exposure. If you're not encrypting at rest or in transit. Missing function level access control. So if you don't have proper access control to execute a particular function, not just like get into a place, but to perform like an admin function, for example, that would be classified with this. There's also the cross-site request forgery, which is another example of an attack where you can force a client's browser to make a client to make a request to an endpoint, and by default, browsers will send the session cookie or send the cookies with that request, so it can force a user to execute something they didn't want to execute. Using components with known vulnerabilities, basically just patch your stuff. Is what this one's categorized as, and unvalidated redirects and forwards means your application can be used to send a user to a malicious website through that legitimate domain that they trust. Okay, so that's the top 10. There's a lot in there. Obviously, you can look a lot more into this. There's way more to the top 10. There's more details, but this is the categorization structure that we typically use when we're looking at web application vulnerabilities. So let's get into what goes beyond the top 10. First up, we got race conditions, otherwise known as CW362. Race conditions is something that's been around since the beginning of asynchronous computing, since multi-threaded environments have existed. It's something that has been classically just been known as a bug, but it can be leveraged to actually be a security vulnerability if it's done in the right way. So it's when the timing of certain actions in an asynchronous environment actually affect the actions of the other environment. Guys, I'm just going to ask if you're talking, I'd really appreciate if you don't do that while I'm talking. Thank you very much. So the race conditions, getting back to this, if you have an asynchronous environment or a multi-threaded environment and two different things should be happening synchronously, but they don't, if the timing of that gets off, if it goes off and something happens out of order, it could become a security vulnerability. I'll give some examples of what that actually is, so some actual exploits that have happened because of this. But first, let's kind of give a visual picture of what that looks like. So it's when you're making an assumption about the order of operations. So let's say the assumption is that we have process X and process Y. Process Y has 2 basic steps. Process X has 4. In an asynchronous environment, where the assumption is that because this one only has 2, process Y has 2, the other one has 4, process Y will finish first. The way that it really works in asynchronous environments is this could actually happen, where process X finished first, because asynchronous environments doesn't mean that 2 different things happen at the exact same time. What it really means is that you have 2 things happening one at a time very quickly. So when you're looking at how a CPU will actually hand off the processes, sometimes if something like process Y starts, but it gets blocked, or it does something that needs to kind of process a little bit longer, it'll jump over to process X, and then if it goes really quickly, it'll just go through all of process X and then go back to process Y. So this can happen, and this is very common in web applications because by their very nature, they're asynchronous. Because you can have hundreds of thousands of concurrent connections doing the same thing at the same time. So it's actually more common in web applications than people realize. So what does an actual exploit look like when you're dealing with race conditions? Well, one thing happened when a researcher took a look at Starbucks gift cards, because these Starbucks gift cards allowed you to hold account balances on the 2 gift cards, and you can transfer the balance between gift cards. So what this researcher found was that if you were to transfer the money account balance between one card and another one really, really quickly, do it a whole bunch of times at once, you end up with more money on the second gift card than you actually had on the first gift card. So how does that actually happen? So it sounds really cool, but the way that it works is actually quite simple. If you look at the logic behind the transferring of funds, the way that it works is the first step it does is it basically checks to see if there's enough funds in the card A. If there's enough funds in card A, the second step is it will update the funds in card B. It will basically add funds to card B. Step 3 would be updating the funds in card A, saying, okay, now there's less funds in card A. So what happens if step 1 happens, but then if someone executes a whole bunch of requests at once, step 1 and 2 happen more times before it gets to step 3. So you've then incremented the value of the gift card in card 2, card B, before it decrements the value in card A. So that check to see if there's enough money in card A actually doesn't happen until it's already lost all its money. So card A could have lost, like, let's say $10, and before it actually does that check to see if it has anything left in that account. So if it started off with 5, it could have already lost 10 before it actually decremented the value. So this researcher found this, reported it, and they ended up getting a bug bounty for it. So I'll give you another example of how this works, and you'll see a trend to testing for these race conditions because a lot of the time it looks kind of similar. So a researcher actually found that they submitted a bug bounty, and they actually I think it's on Cobalt, you could get paid in Bitcoins. So they submitted a bug bounty, it was valid, they got a reward for it. So they got a URL to allow them to withdraw a certain amount of Bitcoins for that reward. But what they did was they got the reward, so they looked at they got their reward, and before they actually submitted it, they took that URL and they basically requested it a ton of times at the same time. So again, this is a web server, processes this request, potentially hundreds, if not thousands, if they've got a really big pipe, of times at the same time. So by doing that, they ended up with way more Bitcoins than they were supposed to actually get. The problem isn't with Bitcoin. The problem is actually with the way that the logic worked for withdrawing the Bitcoins. So the way the logic worked was, first, check if the URL is valid. Second, if the URL has not been used yet, then send the money to that endpoint, to that researcher. And third, mark that URL as invalid. But if you get to step 1 and 2 hundreds or many, many times before it actually hits step 3 and marks it invalid, you've then been able to withdraw a whole bunch more Bitcoin than you were supposed to have gotten. So this is what he did, and then from there got another bug bounty reward because they reported it. So how do you actually test for race conditions? So if you go out and you want to actually look to see where are these race conditions, where are these vulnerabilities present in my code, especially in web applications, how do you do it? Well, you can do it through the best method and the easiest method to find is through white box testing, which means you have access to the source code. So I'm going to go through these 4. Basically what it means, shared resources are usually where you're going to find these things because you can do a whole bunch of things at once in other places in an application. It usually won't do anything. But if you're doing a lot of functions at the same time to a single object, then that can result in corruption. It can result in bringing a system down. Things can happen that you don't want to happen. So if you look for places in the source code where you have shared data, so in the example of the Starbucks gift cards, that account was a shared resource in the database. So it was a value for this account in the database that can be accessed many, many times at once. That is a shared value. Identify that and then see where it can actually be accessed across a number of systems. And then if it's not synchronized, and I'll get to how to synchronize it in a minute. If it's not synchronized, then you will then go and make a ton of requests to that resource, see what happens. So that's the white box method. So if you have source code, you can easily identify where these spots are. But if you don't have the source code, it's often more difficult to test for these things. So that's where we get to black box testing. Black box testing means you don't have the source code and you're basically coming at it from an external attacker's perspective. Race the Web is a tool that I actually wrote myself because there was a lack of tools to test for race conditions. This allows you to do this black box testing against resources. So it's free, open source, specifically made for testing for race conditions in web applications. And before I get to the accompanying application, what it does is it basically allows you to choose a request. You can even submit cookie values with it, so like your session value if you want, if it needs to be an authenticated request. And then select how many requests concurrently you want to make to not only one resource, but you can set up to like 4 or 5 different resources. So if it's a matter of transferring funds between an account and you need to do 2 different things at once, you can do that. And then what it really does differently, and what kind of differentiates it from a lot of other tools, is it will actually do a response comparison. So it will actually compare the responses you get back and look for anomalies. Because that's how you can actually tell when something has gone off, is if it's different from the baseline, if it's a different result, then by doing that, then you know that there's something wrong. I also built a accompanying deliberately vulnerable web application for race conditions. It's set up to be like a bank. You have a bank account, and you can then use the Race the Web tool to actually submit a bunch of requests to this endpoint, and it tells you, you'll find out that you get more money back than it actually shows in your account balance. So let's say you get like $100 back, but your account balance might decrement by $2. It's just an example of doing that. So if you want to see what it looks like to see an actual race condition in a web application, I'd recommend checking that out. It's made specifically for this. If you have Burp Suite Intruder recently added in the function that you can compare response. It actually has a response comparison of sorts. So you can use Burp Suite Intruder as well if you would like. It's not as fast, but it's still a lot of people here have Burp, so it's a really good resource as well to use that. But one thing to be aware of is be very careful when you're testing for race conditions, especially when you're using it in like a bug bounty or against someone else's application, because the testing is inherently a form of denial of service attack because you're sending a whole lot of traffic to one endpoint at the same time. So certain bug bounties have wording like this where they say not to do that kind of testing. So just read the scope very carefully when you're doing this. Obviously, if you're testing your own application, you're good to go, but just be careful because you could overwhelm some resources as well. So how do you defend against race conditions? First off, locks. This is really if you're going to defend against race conditions, if you want one solution, locks is the solution. They're literally built just for synchronization issues, which is what race conditions are. So just use locks. You can use it in your database, you can use it in your ORM, your object relational mapper. Most programming languages have locks built in. File locks exist as well. Going back to programming languages having locks built in, another reason not to use PHP is PHP was not built to be it's not an asynchronous, it's not a multi-threaded programming language. It's not. PHP is not multi-threaded or asynchronous, but Apache and Nginx are. So it relies on the underlying server to do the multi-threaded environment, to have multiple requests come in at once. So it wasn't really built. You can do something called a semaphore, which sort of does it, but if you're doing it across multiple servers, it doesn't sync up. So it's very difficult in PHP to do that. So just keep that in mind. So this is where you would go to like your database, the database level to do locking as well. There's file locks if you're looking at like a local system. So if you look at Microsoft Word and you have the $ squiggly files, that's Microsoft Word saying this file is locked because it's currently in use. And so that's its syntax to know that not to modify it from other sources as well. So some other mitigations, these things are really, they're not going to solve the problem. They're just going to more treat the symptoms. They're going to make it less likely to have a race condition come up. So CSRF tokens just makes it more difficult to automate attacks. A fast database makes it less likely that multiple requests to a database are going to happen at the same time because they're going to get fulfilled that much faster. So it just makes it a little bit less likely. And inserts are they have a little bit more protection against for integrity reasons and against the effects of accessing resources at the same time instead of using updates. So if you're using a database application, you're concerned about this, I'd recommend using inserts over updates as well. So I did a talk on this actually last year at Hackfest. So if you want some more detail, I've got like a lot more detail about race conditions and about how to defend against them technically. Check out that talk if you want, and reach out to me if you want slides as well. I'd be happy to help with that. But again, the purpose of this talk isn't necessarily to go into these as much detail, like to go into these kind of vulnerabilities. It's more to show what kind of vulnerabilities exist that don't really fall within the OWASP top 10. So you can check that out for some more information. Next up, HTTP parameter pollution, otherwise known as HPP. This is a vulnerability that is one of those things that if you don't know to prepare for it as a developer, if you don't know to look for it, then it might not show up in your code. It might not show up as a vulnerability, but sooner or later, it's going to hit you. Because the way that it works is when you're looking at a web application and you send a request to a web application, you're going to see there's parameters. So when you want to send a value to a web application, you'll send a parameter like a equals 2. So if you look at like example.com and you see question mark a equals 2, that's passing the value of 2 with the parameter named a to that application. But sometimes if you see an application, sometimes if you send an application that same parameter name of a, but you send, so it's already got a equals 2, but you pass in an additional parameter with a equals, I don't know, a equals 3 or another value, how does it handle that? The answer is that different application technologies handle that differently. So here's an example of what it looks like. So this is just an example of some ways that some application technologies handle it. So for example, ASP.NET concatenates them with a comma in between them. Python handles them as an array. I believe PHP takes the last one. And they'll cycle between like first occurrence, last occurrence, concatenating them, creating an array, things like that. So each application technology handles parameters differently. So if you're looking for a parameter value in your programming code, in the logic, and you're looking in the wrong spot, something could go wrong, especially if you're doing input validation or you have a web application firewall. So basically, it results in confusion in the application. So here's an example of an exploit using this, is you can actually leverage HTTP parameter pollution to get SQL injection. So if you have something like a web application firewall or input validation that's looking for SQL statements in the query, if you split it up, so for example, in ASP.NET, what would happen here, if you split this up through different, so you look at the Q parameter here, Q happens a bunch of times. Q equals select / star, Q equals star / name, and so on and so forth. So this is really, if you use ASP.NET, because it concatenates all the values with commas, this is what it ends up with. So if you take a look at this, all the commas are actually commented out. A web application firewall, I mean, now they might, but some web application firewalls and some input validation might not actually see this as a SQL injection. They might just see it as a bunch of just random characters that looks valid. They didn't check for it, so it must be valid. And then that's how you get SQL injection. So this is one way of leveraging HTTP parameter pollution to get something else, another more dangerous, devastating attack. As I mentioned before, you can also blacklist web application firewalls. So in this case, it's a way of, similarly to how we did it with SQL injection, if a firewall is looking for the script tags in a query, then if you split it up through, see the A parameter is here multiple times. If you split it up like that, then that's another way of getting the script tag in there. This works less and less now with web application firewalls. However, you can be really creative with this because, as I'll get into a little bit, there's multiple places to pass in a parameter and not just in one spot. So another way is to bypass input validation. And so here's what I mean when I say you can pass it in multiple spots. You can pass it in through the URL parameters. You can pass it in through the cookies, and you can pass it in through a post body. So if you look at this, in this request, in ASP.NET, this would result in A equals 1, 2, 3, 4, 5, 6, because yes, you can pass it in those 3 different spots, but the way that it interprets the order of them also matters. So if you're trying to pass in through a script tag or a SQL injection, it's going to matter the order that you want it to be reassembled. So the way ASP.NET handles it, and I believe a lot of them handle it, is the first spot it will look is in the URL parameters. Second is going to be in the post body. And the third is in cookie values. So this could be, if you use this could really help bypass web application firewalls, input filtering, and input validation to get that vulnerability where you may have been stuck before. And then another example is through, it just makes URLs a little more difficult to parse. So in like phishing campaigns, Hayden was doing a talk on phishing yesterday. If you try to fool a user to click your link, or with like cross-site scripting, it just acts to further obfuscate the URL that you're passing them. So in this case, it looks like they're doing a post action, but really it's hidden through your URL encoded characters. The action on this URL is a delete. So let me give you an example of an actual vulnerability where this happened. On Twitter, so with OAuth, for those of you that aren't familiar, OAuth basically allows a service to you to authorize, not authenticate, but authorize a service to do something on your behalf. So with Twitter, it'll allow a service to read your timeline, to write to your timeline, things like that. So what this researcher found was that it was authorizing Twitter to access, Periscope TV to access their Twitter timeline. If you look at I'm not sure how well you can read this, but if you look at the host parameter value, on the second last line, the host value is periscope.tv. So it's saying Periscope TV is the one that we want to authorize. But you see the additional parameter for host is attacker.com. What Twitter was doing was it was actually using the first value for a whitelist, so it was to check to make sure this thing is a valid host that it's going to use. And then the second one was the one that was actually authorized. So a user would see this, they'd be like, oh, I'm authorizing Periscope TV. But really what happened by passing in that extra parameter is you're authorizing attacker.com to access your Twitter timeline. So it granted the OAuth token to attacker.com to be able to access the Twitter timeline when the user thought it was actually Periscope TV. So this is an example of using parameter pollution to trick users and to really, in this case, gave them complete access to their Twitter profile. So how do you actually test for header parameter pollution? Realistically, the only way you can test for this, or the best way to test for this, is just try it to see what happens if you pass multiple parameters with different values. So the same parameter name, different value. In this case, if you see a parameter, try passing in a different value, see where it shows up, see which one shows up. How does it respond? You can automate this with Burp Suite. This is actually a fairly recent addition they've made. Before, you actually had to be a little trickier with like looking for post requests that had a body, things like that. But now you can actually just look for requests that have parameters in them. So it's a really easy way to see, and if you scope it to your own application, it's way better. So you can see exactly what requests have parameters in them. Burp Suite Intruder you can use to automate testing a bunch of results. So you can pass in like a fuzzing list, you can pass in SQL injection, things like that through the second parameter and see where it shows up. You can look in, I'll get to later on defenses, but basically you can look in your source code for instances where there are parameters that are passed in and see how you handle it. I'll get into more detail later. So the sources for parameters, I mean, this is pretty straightforward, but you can look in form fields, pagination, so like and page equals 1, page equals 2, things like that. Admin page identifiers, so if the admin page is 1, but you pass in a second parameter with 1, 2, 3, 4, 5, the authentication or your access control might actually be looking at the last instance, but the application underneath might be actually requesting or using the first instance. So your firewall might see, oh yeah, they're looking for page 1, 2, 3, 4, 5. That's authorized for anyone, but the source code, the application itself, might redirect you to page 1 and then give you admin page. So look for admin page identifiers as well, because if you can reference those by passing another parameter, that's a way of bypassing that. And again, like I said, just try intercepting all the requests with parameters. So how do you defend against HTTP parameter pollution? Well, first and foremost is testing. So just test to see how this works in your application, see how it responds when you pass in multiple parameters. Again, like I mentioned before, look in the source code, see if you're explicitly checking the first or the last one. In most cases, you're going to see that these source code is the application's just taking a parameter. It's not taking the first parameter, it's not taking the last parameter, it's just taking a parameter. And if you reference back to that the list that I provided before of the different technologies and which ones they take, see what yours is using and see if yours is coded explicitly that way or if it's expecting something else. Ideally, you're going to want to be explicit as possible and try to strip other duplicate parameters out. Again, this is just more of a sanity check to make sure you're explicitly checking the right parameter. And check to see if your web application firewall is doing the same thing. So if you're trusting that to prevent attacks, you're going to want to make sure that it's actually doing its job the right way. And output encoding means that this is just a good practice for general defensive programming. But when you're going to be taking parameters and input from a user, always assume it's malicious. So when it comes back out on the other side, if you encode it, let's say if someone passed in a SQL injection string that bypassed your firewall, bypassed your input validation, and then it goes through to your SQL database. If you were to do output encoding first, it will come up with an error because all the special characters and things that you pass in are really going to be encoded, and so it's not going to be interpreted properly by the database. Same with the script tags. When you pass in when you saw the cross-site scripting earlier, if you encode that before it comes back in the application, it won't execute as script tags, and that negates any attack. So it's just a further mitigation to use. There's a lot of resources on HTTP parameter pollution, so this is a big list of them. Again, reach out to me afterwards, and I'd be happy to share this slide deck with you, but there's a lot on there. And it's cool because a lot of these provide some other attack scenarios to show you like exactly what's been done with this attack. So last but not least, server-side request forgery. This one's actually pretty fun, and it came up in an open source. I was doing a security review of an open source application recently, and this actual attack came up, and we had to put a lot in place to mitigate it. But what it basically means is if an attacker can use your server, your system, to make requests out on their behalf, that's server-side request forgery. So it essentially makes your server into a proxy for the attacker. I'll give you some more details soon. So what can it be used for? It can be used to bypass firewalls. So if an attacker can use your system to make requests out, if that attacker's IP is blocked or they're not on some kind of whitelist, but that system that they're making requests through is, then it's allowed, it's trusted, and it'll get past firewalls. Similarly, this is really interesting. A lot of systems, a lot of web servers don't just have an external facing interface. A lot of them also have an internal facing interface as well. So if an attacker can make a system or a server make requests out for them, they can see what's on that internal network as well. So they can not only make requests out to the internet, they can make requests out to the internal access in the internal network, which is normally not accessible to anyone on the outside. So it's another really, really interesting way to leverage it, and I'll give you an example of that actually being done later on. So a lot of us come into security and we like to do network security or infrastructure security or application security. this is a really interesting way through this particular attack to transition from application security over to network security. So you get to kind of use both. And from a defensive point of view, you have to know both sides to really understand the effects of this. So coming in, a lot of these are exposed through application attacks. So the application will essentially result in this, allowing the attackers to use the system to make requests out. But then those requests out, what do you do with those requests out to other systems? That becomes more of a network problem. I'll show you again later on what that kind of means. And it's useful for enumeration and reconnaissance. The reason is because it essentially turns that server, the vulnerable server, into a port scanning tool for the attacker. And because the requests coming out to the other systems look like they're coming from that vulnerable server, you can't see what the attacker's IP is unless you're on that vulnerable server. So attackers love this because it basically gives them a bot to then make requests out and port scan other things and port scan the internal network on their behalf, and no one knows what their actual IP is. So it could also result in that vulnerable server getting blocked and put on a list that it doesn't want to be put on. And sometimes when you make requests out, if you can force it to make a request out to your own server and it returns the response back in the page, then you can force it to return back a page that has cross-site scripting on it. And so the way that it's introduced is often by developers trying to bypass same origin policy. Basically, I'm going to talk about it a little bit later in defense as well, but same origin policy prevents it's a browser protection that prevents a website, a domain, from making a request out to any other domain that's not its own. There's a way to obviously allow this through cross-origin request sharing, which I'll get to later, but basically understand, same origin policy, one domain, domain A, cannot make a request out to domain B if unless it's explicitly allowed. So if you want to request resources on that other domain, then it will be blocked by your browser. There's exceptions to this, and there's exceptions through like loading in another script from another resource. But for the most part, if you want to go and make a request out to another page and return back like, oh, what does this page look like? Return it back. It's not allowed. So developers, to get around this, what they'll do is they will make the request not on the client side through the browser, but they'll take the request, do it on the server, return it back, and then put it into the page. There's a reason same origin policy is there. So it's developers implement this. It's not a bug, it's a feature, but really it's a bug. So let's take a look at what some exploits are for this. So how has this been actually used to attack certain applications? So first off, querying AWS metadata through SSRF. I had a discussion with, I think, Dave about this the other night, but I'll get to what this means soon. But this is what happened. An attacker found an endpoint, and take a look at that endpoint URL. At the end, there's mediapreview.php, and then the parameter is URL equals. When you find URL equals in a URL, you're laughing as an attacker. It's great. Because oftentimes that'll result in an open redirect. So you can just put anything in the URL and then something else, either the user will be redirected, or what happened in this case is it allows you to load content into the page. So in this case, it only loaded images, but the way that it was checking for images was just looking for the instance of .png or .jpeg. So by passing in, this is the researcher's domain, so I left it in there. But passing in !.png at the end was enough to pass the validation. So they could basically it loaded in Zayat.org into the page, and then just passes a parameter with .png, which does nothing anyways, but it bypassed the validation. So what they did then is, like I mentioned before, is they just created a page called xss.html, which had cross-site scripting on it, and then boom, that page loaded in the browser through this server-side request forgery. So it allowed them to make this request out, bring back a page from another domain, and load it in the page itself, and there they had cross-site scripting. But that's not all. So they got cross-site scripting, and then from there, overly permissive regex is another vulnerability that I would like to briefly cover, but basically, make sure that your regular expressions are done right. That's all I'll say right now. So that wasn't all. Did you know that you can query this IP if you have an AWS instance, and it will return AWS instance metadata? So what they did was, they queried they queried that IP with latest metadata, bypassed the input validation, and it returned back all the instance metadata for that AWS instance. So they not only had cross-site scripting, they said, no, that's not enough. They went further and they got all the information about that AWS instance, and then they went on and they just took over the whole AWS instance. Because that request was coming from, not from the attacker's IP, the request is coming from a trusted IP, which was the AWS instance itself. So this is the danger of getting server-side request forgery, is it's a trusted source. You can make the request out on behalf of that trusted source. So I really think it's important for you to check out that guide. Again, I can send you these slides afterwards. I'd be happy to. There's a guide on AWS about instance metadata. An example of some things that you can get from the metadata is AMI ID, reservation ID, local host name, public keys, OpenSSH key, security credentials for a specific role, security groups, user data. There's a lot. So if you're running an AWS instance, be aware of it. There's the URL for the actual issue. Sorry, that doesn't show up very well. There, check out that guide. So next up, we're going to talk about another exploit for server-side request forgery. And the way this one works was Google actually had a page called, their page was essentially on the Google Toolbox, allowed you to do a bunch of different web stuff. One of these things was dig. So for those of you that are not familiar with the dig tool, it essentially allows you to just make a query out to a DNS server and return back DNS information on a specific domain. Here's what the interface looked like. You can make a request. I'm not sure how well you can see this, but the name, you could pass in a domain name and pass in a name server to use, and it'll return back the DNS information for that. But if you take a look at the request, I'm not sure how well you can see this, but you can see that there's a parameter called name server equals. And if you go back to the last page, it was 8.8.8.8 was the one that was used. But if you just intercept it and change it, you can modify it. What the attacker did was they just changed that name server to 127.0.0.1. For those of you that don't know, that's the loopback interface. So the Google application was then making a DNS request, a dig request, to itself, and it was running a DNS server on it. And then from there, it allowed it to return back to the attacker all the DNS information that it had through enumeration, all the DNS information it had for the internal Google network, because it had that internal interface as well. So the attacker did that. They basically just ran through, they just guessed a whole bunch of domains in the internal Google domain, the Google DNS server, and they found, basically they just enumerated the whole Google namespace. So they found out a bunch of stuff about internal Google network. Fun fact, Google was actually running a Minecraft server at minecraft.corp.google.com. So they reported this to Google. Google fixed it. They gave them a reward as well for it. So this is another instance of having an internal interface and allowing, when you get this vulnerability, the server-side request forgery, making a request, allowing it into the internal network in a way that would never have been exposed before. So it can be particularly dangerous. How do you test for it? So realistically, if you're looking for if you're doing requests, you're going to see a URL. If you see a URL anywhere in a request, there's a lot of fun things that you can do with it. But for this particular instance, try changing it to some other things. So change it to another remote host. So see if you can actually reach out to another host on the internet. If you can, maybe you can reach out to your own host and return back cross-site scripting or return back something else. Play around with it. See what you can reach. Try the loopback interface, right? In the case of Google, it allowed them to query itself and then return back trusted data. There may also be other things running on that local host too. It's not, it very well might be that the web server is not the only thing on there. It could be running an SSH server, it could be running, another web server on 8080. It could be running a whole ton of things. A lot of people are cheap. They just want to use one server. It's very common. Try checking that local interface. Try the local IPs for that local network. See what you can see behind that server. Because you can't reach that from the internet, but you can reach it from that server. If you can do that, then that's pretty dangerous. Try different protocols. So I'm going to cover what that means a little bit, or I'm going to give you some examples of more of these later, but HTTP, if you go into your browser, HTTP:// is not the only thing that you can use to query a resource. You can actually use other things like file. So if you go in your browser and you look at file:// and then you actually reference an actual directory location, if Most browsers will return back your local directory instance and will show you the information. I believe Firefox does it a lot. But using file, if you can do this to another server and you use the file URL wrapper, if it has the proper permissions, you might be able to query some sensitive data. So if you have a URL in a browser, in a vulnerable application, you see a URL in a request, try changing that to file://etc/PASSWD. It's the Etsy password file. If it's a Linux server, that basically gives you the password file that you can then crack, and it gives you all the passwords on that instance. So there's a lot of other sensitive files. People that are in forensics especially are going to really be good with this thing because they know a lot of the sensitive locations on a local web server or any server. So talk to your local forensics guy if you want to understand what you can look for. There's also SSH, FTP. There's a ton of other ones, but there's other protocols that you can check for, and it will return back data through that protocol. So you're not trying to query an SSH server over HTTP. That won't work. But if you use it over SSH protocol, then that will work, and you can get back data from that server. Try a different port. So as I mentioned before, a lot of web servers not only run on 80, but you can try 443 obviously for HTTPS. Try 8080, very common, or 8000. A lot of developers either test on that or they have other services that are running on those that are web services, but they may not be publicly exposed. So try using that as well. Burp Suite Intruder is good for automating it. It just allows you to just iterate through a whole bunch of these things. So like all the things that I've mentioned to change the URL to, you can just automate it through a word list with Burp Suite Intruder. And then sort by response size, because the smaller ones are usually going to be like a no response back. So moving forward, when I mentioned looking for seeing what you can reach, trying to ping out to external services, if you don't have your own server set up that you want to ping when you pass in like an external domain, Burp Suite Collaborator is a fairly new thing in Burp Suite that allows you to, they give you a unique URL, and every time it gets a request to that URL, it'll show up in Burp Suite, it will show up as a potential vulnerability, as a hit. So if you don't want to spend like $5 on a DigitalOcean server, like $5 a month, then you can just use Burp Suite Collaborator, and that helps as well. So what do you do to defend against this? As I mentioned before, same origin policy exists for a reason. So developers will look for workarounds like JSON-P, which is JSON with padding, or they'll do something like doing it on the server side and then returning it back. Don't do this. As much as possible, avoid doing this and use CORS, so cross-origin request sharing. Basically allows you to set up on a server that you own, set it up. As a rule, it will return it in the header, and it will say, this particular domain, or any domain really, you can say this domain or any domain can access script resources or access resources on this server. There's a lot more to cross-origin request sharing, but it has been made to help you bypass same origin policy explicitly. So as a developer, look for that instead of trying to use some other workaround like JSON-P or doing it on the server side. So just as a best practice, a lot of us know this already, but try to whitelist as opposed to blacklist. But in the case of server-side request forgery, you want to explicitly say if you have to. So if you actually have to do things on the server side, which it happens, like everyone has different business cases. Applications are built for different reasons. I'm not going to say that it's never going to come up that you have to do something like this on the server side. If you need to do that, as much as possible, whitelist specific domains. So you want to only make requests out to this domain. So an attacker can't make a request to their own domain or to the internal AWS instance metadata. Explicitly allow only certain domains and IPs. But not only that, explicitly allow certain protocols. So the HTTP:// part, remember how I said you can also use file, SSH, things like that? Explicitly only allow HTTP or HTTPS. So the more explicit you are with this, the better, and the less likely any kind of outbound request is going to turn into a vulnerability. And then, just as good practice, either don't have an internal interface on your web server, or put up some kind of access control. Use IP tables to filter traffic, or have a firewall in between it, or some other way of trying to disallow that server and remove it from that internal network as much as possible will reduce the effects of this vulnerability if it actually comes in place in your application. So this is more of a preventative measure, but it's also a good practice. And why would you want to whitelist protocols? Well, here's an example of the default ones that PHP comes with, and I'm picking on PHP a lot, but it's really easy. here's some of the domains that the protocol URL wrappers that it comes with. So as you can tell, there's some on here that can be, you wouldn't expect at all, but it returns data through that protocol. So there's more, there's a few more, take a look at that URL. But essentially you're gonna want to make sure that you whitelist this as much as possible. So let's review. OWASP top 10. I'm not gonna go through them again, but you can take a look here. These are the top 5, this is another 5. The top 10, none of these actually fit within those top 10. So if we're giving developers this top 10 list, or if we're even as, like if we're a pen tester, or if we're giving it to attackers, or we're testing our own applications, and we're trying to use this list as the de facto list for reference to try to attack these applications, it's not enough. There's so much more beyond it. So these 3 that we talked about, race conditions, HTTP parameter pollution, and server-side request forgery. None of those 3 fit within any of those categories neatly. Lately, it's become a little more broad in the release candidate, which I'll get to in a second, but they still don't fit. So you have to understand as a developer, as a pen tester, as an attacker, as a security professional, that there's more than just this top 10 list that you need to know when you're looking at web applications. So briefly, I will discuss the OWASP Top 10 2017 release candidate. So this came out recently. This is the new one. The one before this was 2013, so it's been time for an update for a while. Right now, it's in release candidate phase until public comments close on June 30th. So in July or August, you'll see like the full version. It might change. It is subject to change now, but right now, this is what it looks like. Here's the changes. First off, is A4 is broken access control, basically merged 2 of them together. So anytime an attacker can bypass authentication or authorization, it falls under that category. Insufficient attack protection. This one's controversial. So if you look up like OWASP Top 10 A7 controversy, you can find out more. I'm not going to go into the drama around it, but basically a lot of people disagreed with it. What it means is that what this category means is developers should implement logging, detection capabilities, automatic prevention capabilities for exploits. So you can look into it later, but that's basically what the category means. A10 is the last new one, under protected APIs. It's very broad. It basically means like it's covering APIs, things like SOAP, REST, RPC, stuff like that, which is weird because in the past, the OWASP Top 10, in my mind at least, and to a lot of people, referred to not only web applications, but APIs, because they were web services. So it's weird that they added another category for it, but regardless, they've done that. So the thing is, it still applies. All of these 3 vulnerabilities that I mentioned don't fit within those OWASP Top 10 categories. So if I was going to leave you with one final message, beyond the fact that you now know, if you didn't before, 3 new attacks that you can use, 3 new things that you can defend against as a developer, you now know more about these things. But if I was going to leave you with one thing, if you were to remember one thing from this presentation, it's that the OWASP Top 10 is a great starting point. Don't get me wrong, it has its place, but it's not all that there is when it comes to web application security. So when you're referencing this and giving it to developers, say, here's a great place to start, but there's more. But if you get these things, then you're in a pretty good spot. Just keep learning. The key is to keep learning. And I think that's why we're all here at this conference. I think that's why we're all in this industry, is because we know that it's always changing. If you don't keep up, then you're not going to be able to continue in this industry. You're not going to do well because it's changing at the speed of light. So you need to keep up with this as much as possible because there's always new vulnerabilities coming out, always new categories. The OWASP Top 10 covers a lot of them, but man, attackers are smart. There's new ways every day. So how do you actually keep learning? So I'm going to give you a few resources to follow up on so that you can stay in the know. So you can understand some of the nuances in the changing landscape of especially web application security. It's always evolving. First one is the HackerOne. I know we had BugCrowd as a sponsor, but they also do bug bounties, and I believe they have some public disclosures that they do. But HackerOne's really good for this because they aggregate this all in one place called the Hnatiw feed, where it's disclosed bug bounties. So you'll see reports from these researchers that are finding these vulnerabilities in these applications and submitting them. And it's updated very, very regularly, like usually daily. Twitter is probably the go-to place for a lot of us. The problem with Twitter is that if you're not following the right people, then you're not going to get the message. So it takes a while to get to that point, but what I would recommend is start by following some of the speakers here. If you really liked one of these talks or this subject that one of the speakers is talking on is really interesting to you, it's very likely that they're on Twitter. Follow them and then see who they follow, see what they tweet, see what they retweet and what they like. start with that and then build it from there. But realistically, for me, when I'm looking for, when I'm trying to understand and I'm hearing about the latest application attacks, Twitter is usually the first place that I hear it from. There's also Reddit has a subreddit called rnetsec. It's a good spot. I don't really use it anymore, but I know a lot of people do, so there's another resource for you. And something I actually found recently that I put on here was there's something called the Zero Daily Newsletter, again by HackerOne, where it comes out daily, but it's a small little newsletter that gives you some of the latest bug bounty reports, gives you latest like some tweets, and gives you some write-ups that have come out about different application security attacks. And I've actually found it to be pretty good quality. So it's every day, it's small, it's easy to keep up with. It's a really good place to start. So with all of that, I want to say thank you very much for coming. If you have any questions or you want to reach out, if you would like the slides, please come up to me and ask me after. For those that are going to be watching on the video, just reach out on Twitter. My DMs are open. That hasn't blown up in my face yet. So reach out to me anytime, and I'm really happy to answer any questions. So thank you very much. I don't think we have any time for questions, but if you have any questions for me, I'd be happy to answer them anytime. So please come up to me. I'm trying to be as friendly as I can. Thanks.